Okay, so we'll discuss more about paper when everybody joins in, more people join in. So now we are basically starting with memory testing. अभी तक हमने सर्किट की टेस्टिंग करी है एंड वी जनरली से कि अगर हमारा कोई आईसी है उसमें कोई पार्ट इज फॉल्टी वी डिस्कार्ड दैट आईसी कंप्लीटली because mainly the function of the IC will not be met. But when it comes to memory testing, this is very much different from the logic testing that we have done. The reason being, हम memory को अगर memory तो बहुत dense structure है, तो अगर उसमें एक भी सेल खराब है तो we cannot discard it directly. Otherwise yield बिल्कुल जीरो ही हो जाएगा, क्योंकि कहीं ना कहीं किसी ना किसी पार्ट में प्रॉब्लम होगी ही होगी, because it is such a dense structure. मेगाबाइट्स में है, एवरी बिट इज रिप्रेजेंटेड विद वन रजिस्टर एंड वन रजिस्टर इज, अगर SRAM है तो 6 ट्रांजिस्टर से होगा, DRAM है 4 ट्रांजिस्टर से होगा, सो वी कैन हैव एनी एरर. सो इट इज वेरी मच डिफरेंट फ्रॉम द लॉजिक टेस्टिंग. इट इज अगेन इम्पॉर्टेंट बिकॉज मेमोरी जो है वो बहुत बढ़ती जा रही है. वी आर हैविंग मोर एंड मोर कॉम्प्लेक्स सर्किट्स, so we are required to have more and more memory implemented on the chip. Not necessarily primary kind of memory, but definitely secondary and tertiary memories are also required somewhere. We studied about fault, error and failure. Fault क्या है? Physically कोई problem होना. So physical defect which causes system to fail is referred to as fault. Every fault may cause an error. So the result of fault is an error. अगर कोई एरर हो रही है किसी आईसी में, then we say that the IC has failed. So fault cause error which result into failure. This needs to be remembered. When it comes to memory testing, what we basically do is, suppose we have a memory structure, we have so many registers implemented, each register is representing one bit. A quite dense structure, megabytes में है memories, gigabytes में. So now what happens, suppose I test this location and this location is identified as faulty. Some fault occurred and we say that this is not working properly, this cannot store data. Memory को करना क्या है, या तो 0 रखना है या 1 रखना है. There may be a transition from 0 to 1 or 1 to 0. That is all that can happen in a memory. All these tests, किसी भी एक टेस्ट के लिए this memory location fails. So what we do is we rewire and we say that instead of say reading the address as 0th row 0th column, this will 0 0 location, this will be 0th row first column, this will be 0th row second column. So if I have a fault at 0th row second column, I rewire the structure and instead of reading 0 to, suppose there are extra memory locations already created. अगर हमारी memory 1024 bytes की है, so we will have some extra memory locations made by default. So what I will do is I will rewire the structure such that if I have an input address of 02, instead of moving to this location, it will move to this location. Right? This would be 5, 5. This is an extra memory location and which is rewired to 02. कि अगर ये fault में है तो कोई बात नहीं, the address will be redirected to a good memory location. That is basically what we do in memory, in case of memory test faults. So this entire thing is explained over here. Multiple faults may be present in any memory chip. The yield of memory chip would be nearly 0 since every chip has defect. बहुत छोटे छोटे हैं ये locations, बहुत dense है memory. So before during manufacturing tests, the faults are not only to be detected but also their locations are to be diagnosed now. We don't just want कि कितने memory locations faulty है. We want कि कहाँ पर fault है ताकि हम उसको rewire कर सके to a good memory location. As almost all memory will have fault in some cell, there are redundant, that is extra cells in the memory, which is manufactured during fabrication. Once a fault is diagnosed, the corresponding cell is disconnected, so 02 is disconnected and a new fault-free cell is connected in the appropriate position. It does not mean that we move it. We simply use logic and we simply say कि if the input address is 02, read it as 55. Right? This replacement is achieved by blowing fuses to reroute defective cells to normal spare cells. The sole functionality is either of these four. जीरो स्टोर करना है या एक ट्रांजिशन होगा, इससे ज्यादा कुछ नहीं होगा मेमोरी में. Therefore, it is very different from logic testing. If we look at the structure of memory or architecture of memory, this is the core memory, the central part, memory cell array. Here my memory cells are stored. To access each memory cell, I need an address. That address is taken up from an address latch and is divided into row decoder and column decoder to identify the memory cell in the array. Right? Nowadays we can have the third dimension. The work is going on for third dimension as well. So these identify the address. Then I have to read or write something in the memory. For that, from the lower end, I have a data register. What this data register does is, it stores the data initially. अगर मुझे write करना है memory में कुछ, तो I'll upload my data to this data register. Then using this read, write and chip enable, I'll enable the write option. So that whatever data is stored here in the data register, this goes to write driver, and this write driver writes the data at the identified location. ठीक, read करना है तो क्या होगा? The location is identified using row decoder and column decoder. From that location, the data is sensed by a sense amplifier. Since the data is only 0 and 1, there may be some fault in memory, because data कैसे store हो रहा है? In the form of charge on a capacitor. This we studied in VLSI design. अगर ये capacitor charged है, then we say the output is logic 1. If the capacitor is having no charge, we say this is logic 0. So we are simply sending the charge on the capacitor at a particular location to the sense amplifier. What sense amplifier does is, it simply compares the voltage it is getting from memory cell and will convert this into logical data 0 या 1. अगर बहुत small data है, small voltage है, it will say this is logic 0. If the voltage is greater than the threshold voltage, we say this is logic 1. So your sense amplifier will read the data finally in digital form. ठीक है? That data is going to data register from which I can take the data out. Right? Additional circuitry includes a refresh logic. Refresh logic means your memory has to be refreshed. Everything in the memory, everything stored in the memory need to be removed, and 0 needs to be entered. So we have a refresh logic, which when enabled will identify every column, every row and put the value as 0. Therefore, I have these thinner arrows, they indicate the control flow, how the control is done. The darker arrow, bold arrow, they will show the data flow, how is data flowing. So your refresh logic is controlling column decoder, row decoder and the data register. जैसे ही हम refresh logic को enable करते हैं, column decoder starts to read from 0 to maximum, row decoder starts to read from 0 to maximum, such that every cell is accessed, and at the same time data register loads 0, so that write is enabled and everything goes to 0. Right? Error कहीं भी हो सकता है. The error can be in the memory cell, which we already discussed. If there is a fault in memory cell, I need to rearrange the location. Right? There may be a fault in the decoders, so that the correct location of the cell may not be identified. Even if it is identified, the error may be in the sense amplifier, which may not be able to detect correct value of 0 or 1. Even if I am able to read, the write driver may not work properly. It may not be able to transit from 0 to 1 or from 1 to 0. So there are so many possibilities of faults which all need to be catered. However, we generally consider specific kinds of faults. Of those faults, the first class is permanent and non-permanent. As the name suggests, permanent fault हमेशा रहेंगी. नॉन परमानेंट कभी रहेंगी कभी नहीं रहेंगी फॉर डिफरेंट रीजंस, बिकॉज बहुत सी एक्सटर्नल सर्किटरी भी है. So permanent fault exists indefinitely, which can be modeled using a fault model. A particular stuck at fault. Permanent fault है, एक बार stuck हो गया तो वो stuck ही रहेगा. This is caused by bad electrical connection, a bridging fault for an example. The broken component, so stuck at fault, chip logic error और burnt chip wire. एक बार अगर इनमें से कुछ हो गया तो वो exist करेगा ही करेगा. Non-permanent fault means they are present for some time and may occur randomly. These may be due to environmental factors or due to non-environmental factors. Environmental factors means आपका temperature बढ़ गया IC का, temperature बढ़ गया तो उस वजह से कोई ना कोई connection गड़बड़ काम करने लगा, but that is temporary. As soon as your temperature falls down, the connection may work properly. So in that type, in the non-permanent type, again we have transient and intermittent. Transient means कभी कर रहा है कभी नहीं कर रहा है, for and the system reverts back to good machine whenever the condition is removed. For example, your temperature rise. Intermittent means these are non-environmental condition. Again वापस system सही कर सकता है, but we are not sure कब करेगा. जैसे transient में तो मुझे पता है if the temperature falls down it will work properly, but in intermittent suppose there is a loose connection. लूज कनेक्शन कभी लूज हो रहा है कभी टाइट हो रहा है. आई एम नॉट एबल टू आइडेंटिफाई कि उस किसी एक पर्टिकुलर टाइम पे इफ द कनेक्शन इज एक्चुअली लूज और नॉट. सो दोज आर क्लासिफाइड एज इंटरमिटेंट फॉल्ट्स. Whatever the fault be, I need to test a memory at 3 different levels. The first is chip testing. Chip testing means only the memory array. So only the memory array needs to be checked using some memory fault model. Once the chip is tested, memory cells are working properly, I need to work with chip select and control logic. Means the location choosing, row decoder, column decoder, ये सही काम कर रहा है या नहीं कर रहा. Then the third step would be, if everything is okay, if I am able to identify the memory location as well, I need to go for other टेस्टिंग. फॉर एग्जाम्पल टेस्टिंग द रिफ्रेश लॉजिक. रिफ्रेश इनेबल करते ही सारी मेमोरी जीरो हो रही है या नहीं हो रही है. अगेन एरर डिटेक्शन एंड करेक्शन लॉजिक. दिस इज जनरली एन एडेड सर्किट विच इज रिक्वायर्ड टू आइडेंटिफाई द लोकेशन ऑफ द मेमोरी. तुमने वो पढ़ा होगा इंफॉर्मेशन थ्योरी एंड कोडिंग? नहीं, अभी नहीं पढ़ा. You will be doing it in the next semester, maybe 7th semester, where you will study how these codes are executed so that they can identify how many bits are in error and which location of the bit is in error. Right? This is a probability based method where we can identify, we can detect where the error exists. Some coding methods are such we can correct the logic as well, correct the identified fault. Correction is very easy. If the identified fault is 0, so the correction option is only 1. कि अगर 0 is a fault, means the value should actually be 1. Similarly, ulta. If the identified fault is 1, then the actual memory value should have been 0. So we have this memory detection and correction logic on the board. So different boxes are made here. I am testing the chip first. Multiple chips may be placed in the form of an array. I have to look into the fault for identifying the chip. हर chip के अंदर बहुत सारे memory bits होंगे, right? And once I have identified the correct working of this section, I will go for other logic circuitry on the board. ये जो हमारा control signal है, error detection, correction, logic है, this is a logic circuit. Whatever we have studied for logic circuit fault detection, that we can apply here. We can have different memory faults, but in general we'll talk about these faults in the lower table only, because whatever faults are mentioned in the upper table, they are reduced to certain 4 number of faults. Because for example, read the functional fault A says cell stuck. The cell may stuck its value to 0, the cell may stuck at its value to 1. We studied it as stuck at fault. So that is a stuck at fault. Suppose J is open circuit in address line. So open circuit in address line means it is not able to identify that address line. So it is not able to identify that chip location. So again, that chip, whatever value it had, it will be fixed. So again, this is a form of stuck at fault. Therefore, we can collapse these many faults into 4 important faults: stuck at fault, transition fault, coupling fault, and neighborhood pattern sensitive fault. Today we will look into stuck at fault and transition fault. Tomorrow we will talk about coupling and neighborhood pattern. Here fault G, this is identified as short circuit between data lines, which we identified as bridging fault, right? Bridging fault is a form of stuck at fault here, considered for memory. The logic value of a cell or a line is always 0, तो हम उसको कहते हैं stuck at 0 fault. If the value is always 1, we say this is a stuck at 1 fault. The notation now will be represented like this. For all, this symbol means for all conditions, the value is 0. This is stuck at 0 fault. Similarly, for all conditions, the value of the memory is always 1. This is stuck at 1 fault. The memory testing is done in the form of state transition diagrams. जो हम डिजिटल में पढ़ते थे, FSM में पढ़ा था, same way here. Each memory bit can have only 2 values, 0 and 1. Therefore, 2 states are identified, S0 and S1, right? A good cell, here it is written state diagram of good cell. Good cell means जब उसको कहो 0 लिखो तो वो 0 ले ले, जब उसको कहें 1 लिखो तो वो 1 ले ले. So each arrow indicates some write operation. So suppose I am talking of S0, that is state where memory cell has a 0, and I execute a write 0. So that write 0 will bring me back to the same state. Whereas the state will change when I operate with write 1. Similarly, I can say from state 1, I will switch back to state 0 when I have write 0 operation executed. And if I have write 1 operation executed, it will remain in the same state. Now we represent the state diagram in the form of for modeling the stuck at and transition fault. The first here is shown stuck at 0. Stuck at 0 means हमेशा यही मिलेगा मुझे value 0. Either I write 0 or write 1. Therefore, your state diagram is S0 with 2 arrows, write 0 as well as write 1. Right? Stuck at 1 fault क्या होगा? The memory location is the memory state is S1 and it will remain in S1 only even if I try to write W0. W stands for write. Transition fault. Transition fault, दो ही transition हो सकते हैं, 0 to 1, 1 to 0. It means initially my state was 0. I wanted to write 1 so that it changes to state 1. But this may not happen. So the transition fault is represented over here, which simply says up arrow slash 0. Up arrow means write 0. Right? Transition to 0. So if I am at state 0, write 0 will remain here. Write 1 will also come back to state 0 only. जबकि state 1 पर operation सही है. State 1 पर अगर हम हैं and I am executing write 1, it is in the same state. And if I am executing write 0, this is moving to state 0. It means 1 to 0 transition is okay. जब मैं write 0 कर रही हूँ तो 1 से 0 हो रहा है, लेकिन 0 से 1 transit नहीं हो रहा है. These notations are very important for March test. Right? March test is the algorithm which we use for testing the memory faults, specifically stuck at and transition faults. These are simple symbols which we need to understand. R means read, W means write. If I am writing R0, this is read 0. R1 is read 1. Write 0, write 1, normal. Then I have an up arrow. Up arrow simply means that I have to write a 1 to the cell which already has a 0. That is the transition which we were talking about in this slide. transition from 0. This is not happening. This is fault. 0 से 1 नहीं जा पा रहे हैं. Up arrow means writing 1 into a cell which already has a 0. Down arrow, try to write 0 to a cell which already has 1. Up and down simply means complement the cell content. 0 है तो 1 कर दो, 1 है तो 0 कर दो. So it will check for both the transitions. The bold arrow. Abhi this book, this Bushnell, this uses this double arrow, right? Some other books use it as bold arrow. So bold arrow says that increase the address by 1, right? We always move along the row first, along the column followed by row. We always form this zigzag pattern. So when I say increase the memory address order, if I am standing here, I should read the next memory here. If I am at the end, I should read the first location of the next row. Bold arrow downwards, decreasing memory address. Upward downward, address can either be increasing or decreasing. Right arrow, write a 0 to a cell containing 0 only. Right? ऊपर अगर arrow है तो 0 उसमें पहले से, लेकिन अब मुझे 1 लिखना है. Right arrow means write 0 to 0. This should be a left arrow. Write 1 to a cell containing already 1. This we will use later when we will work on with the marks test. Double arrow rightwards, the X value, don't care. For all indicates the memory write operation. Any of these arrows. Maybe write 1, maybe write 0, maybe to change from 1 to 0 or 0 to 1. Any value, double arrow as well. I oblique F. I is the fault sensitizing condition. That is, you are moving with some arrow, and F is the faulty cell value, right, which may be 0, 1 or X. I can have multiple faults identified here. Using these notations, we have the algorithm given over here. What it does is, march test simply means throughout the memory location, keep on marching. Matlab, read all the memory locations. So what we do is, we march element up and down with right 0. सबसे पहले मैं सारे elements को right 0 कर देती हूँ. So I moved from here and I ended here to the other end. I wrote every cell with 0. तो सबकी testing हो गई for right 0. Now I will move upwards, backwards and march again, and I will try to read 0. 0 read हो गया. Then I'll try to write 1. So what I am doing here is, in the first step, I have tested for write 0, whether my memory is able to take 0 or not. In the second step, second march, what I am doing is, I am trying to read if my memory has stored the correct value or not. If yes, if it has already 0 there, then I'll write 1. So I'll again test for 0 to 1 transition as well as writing 1. So multiple tests are performed simultaneously, but in the same sequence. Fine. Lastly, अब मैंने वापस start किया. I started from this end and I marched to here. Now I start again, and I'll do the next march such that now whatever written value I had written 1 in the last march. I will try to read that value if it is read properly or not. Once it is read properly, I will try to write 0 now. So I have now transition from 1 to 0 performed. I have read 1 performed. Right? Transition fault पता चल गई, stuck at 1 fault पता चल गई. नहीं, stuck at 0 fault पता चल गई. Write 1 तो correct value है. In this step, I have read 0. तो अगर 0 रीड नहीं हुआ है, it means there is a fault. So stuck at 1 fault पता चल गई, and I have a transition from 0 to 1, and here I have written 0. Here I have written 1. That is the only 6 things I need to test for my memory. ठीक है, ये तो हो गया चिप लेवल टेस्टिंग मेमोरी के लिए. बाकी सब कुछ तो लॉजिक है. वी कैन इम्प्लीमेंट द लॉजिक टेस्टिंग दैट वी हैव डन ऑलरेडी. Right? Here we will stop for today, and we'll see this March test with an example tomorrow and work with other faults as well. Online students, any problem in the exam paper? कोई दिक्कत नहीं थी पेपर में? I'll show you the paper by this week, somewhere near Wednesday. I'll show you. Okay, fine. That I'll do today. I'll upload it in the Teams itself. You can check it from there. Okay, so that is all for today. We'll meet tomorrow in the physical class. I'll not be logging in into the Teams from tomorrow. Okay.